Okay, we're going to look at determinants right now. Let's write that on the paper here. We're going to focus on matrices that are 2 by 2 and 3 by 3. So first, 2 by 2 determinant. So if we look at a matrix such as this, A, B, C, D, if you put lines that are sort of look like or remind you of absolute value lines, this is mathematically saying find the determinant of these for when it was a matrix. This just says it's a matrix. This itself is a command to find the determinant. The method that you use to do that is you do the top left one times the bottom right one. You do A times D and subtract from it the top right one times the bottom left one, B times C. So let's look at an example of one when it would be, say, for -2, 7, 5. Let's make this one we'll leave it that way. So the determinant of that for -2, 7, 5 is going to be, I guess we'd say equals now, is going to be 4 times the 5 minus the 7 times the -2. 4 times 5 minus either -2 times 7, 7 times 2, doesn't matter, equals 20 plus 14 equals 34. So 34 is the number that itself signifies the determinant of that. So the determinant always boils down to a single number. Second part now, we're going to look at 3 by 3 determinants. There are two methods of doing this. One of them is using diagonals. And what that is having a 3 by 3. In fact, let's draw one out here first. Let's say 1, 1, 2, 2, 4, 3, -1, -2, and 1. Okay. And diagonals would be taking these two and writing them over again, and then you would take 3 diagonal amounts. You would add these up. Well, I think, and then add them this way, and then take 3 this way. Actually, I think it's multiply these and then add them. And then you would subtract these 3 from the other ones. And it all works out. There's ways of doing it. It's not my preferred method. Certainly a good one that you can follow in the textbook and do if you wish. But instead, I am going to do, instead of that first one, I am going to do expansion by minors. I like it because it uses this one, the 2 by 2s. It breaks this down to 3 smaller parts. So what it does is it takes, we call this number A, this one B, and this one C. And the formula is A times a minor determinant, a 2 by 2, a smaller one, subtract B times another determinant, plus C times another determinant. And here's how we do it. The A is 1. And I'm going to multiply it by a determinant that is going to be not touching either the row that A is in or the column that A is in. That means those numbers are the ones we'll use, 4, -2, 3, and 1. So essentially, because we're using the 1 here as a multiplier of this determinant, we don't use the numbers that are horizontally or vertically connected to it. We use instead 4, -2, 3, and 1. Subtract from it what B is times another determinant. The same concept will apply. We won't use numbers that are horizontally or vertically connected. The other 4 are the ones that make up its minor. A 1, a 2, a -2, and a 1. So these 2 and these 2. And then we're going to add to it. So this is adding this, subtracting this one, adding this one. This number, so that happens to be a negative, so we'll go like that. But again, we will not use the ones that are in the same row or the same column. We'll use 1, 4, 2, and 3. 1, 4, 2, 3. Now we multiply these together, so it's 1 times 4 times 1 is 4, minus, well, 3 times negative 2 looks like a negative 6, minus a negative makes it plus 6. Okay? And then we're going to subtract 1 times 1 is 1, minus, oh, that's negative 4, so that's going to be plus 4. And then plus or minus makes this minus 1 times 1 times 3 is 3, minus 4 times 2 is 8. So we're going to have 1 times 10 is 10, and this is 5 times 2 is 10, minus 10. This is going to be minus, well, 3 take away 8 is a negative 5. Negative 5 times negative makes this a plus 5. So 10 take away 10 is 0, plus 5, our answer is 5. So this 3 by 3 determinant boils down to 5. So you can do the diagonal method if you prefer, go and find it on your own, or come in for help with it if you wish, because I can do it then, but I'm going to show the one I like. And then also this one you have to do for any 2 by 2s. You can do this also in the calculator. Right? So let's take, say, this first one, and let's enter it in. Here is number 3 for me. Oops, I did not do the edit for that. I need to actually make it. So I'm going to do 2 and 2. And the numbers I had were 4, negative 2. Whoops, I have to delete it because I didn't press enter after that 4. Okay, enter arrow key I think works, but not that. So now I'm going to do negative 2. And the arrow key doesn't work, so I can move that way though. It's easiest if I do enter. Then I'll do the 7. And then the 5. Second matrix, C. Oh, it did this down here. I don't want to, I need to clear out of here first. Mode and clear. And I get 4, negative 2, 7, 5. That's the correct one. Get the determinant, second in matrix, move over to math, and the first command is determinant, DET. Press 1. And now I'll say which one it is that I want. It's the C one, but I have to go in and tell it that by going down to C, the pressing 3 or enter. Now the determinant of C is 34. Ooh, good, that's what I got 34. Do the same thing with this one, and you'll get the number 5. Now, let's go to a different thing that has to do with determinants. These are the first things. This is ways of getting the determinants. Here is a way that can be used now. Someone came up with this, named Kramer, so we have Kramer's rule. Okay, so Kramer's rule. Let's take a system of equations. X minus y plus 2z equals 3. 2x plus 3y plus z equals 9. Negative x minus y plus 3z equals 11. Solving a system of equations. Again, there are so many different ways of doing it, and you've been doing some of those different ways. You've solved them by hand. You've used augmented matrices and solved that by hand. You've done an augmented matrix and solved that by calculator. You can also do Kramer's rule, solving it both by hand or by calculator. And so let's see what Kramer's rule is. We are going to make 4 determinants out of this. First, we're going to ignore these answers, and we're going to make a determinant with all, or a matrix and then a determinant with all of these coefficients. I'm going to call this determinant the D determinant. D for determinant. Okay? And I'm just going to go straight to the determinant. 1, 2, negative 1, negative 1, 3, negative 1, 2, 1, and 3. Now, If I put that in the calculator and tell it to give me the determinant, that will equal the number 19. Now, what I'm going to do is I'm going to use that, and I'm going to use some others. In fact, here's what. There's one where I'm going to say dx. And that's a determinant where I use the same coefficients, except the ones that go with the x's, I do not use that. I use only the answer ones in those places. So I remove the coefficients of the x's and replace them with the answers over here. So that's 3, 9, and 11. The y and z columns stay the same. That's dx. I can also do a dy and a dz one. The pattern is the same. dy will be this determinant, but it will be with the y's taken out and these numbers put in that place, 3, 9, 11. dz will be the same thing, same type of thing, but as you see from the pattern now, the coefficients that would be with the z's are removed, and 3, 9, and 11 goes in there. Well, what happens here is that Kramer's rule is that if you want to figure out what x is, you take the determinant for x and divide it by the main determinant, and that gives you the value of x. Since the determinant for x equals negative 38, I can follow this by saying that negative 38 is the result of the determinant of dx divided by the main determinant, 19, and that's negative 2. So the x value is negative 2. Negative 2 for the x, and then y and z. So if you put this into the calculator, you will find it, you will be able to get the determinant for that, and then divide it by 19 to get that one, and the same thing for this one to get that one. I'm not going to take the time right now to do that. Do that on your own. Usually, you can do it for practice right now, and then put the answers up here. I'll do it on my calculator at the same time here, and then so you can pause the video and enter it into your calculator, and then come back, and in just a few seconds I will put up the answer here, and then the same thing for the z one. dy is the number 57. So y is dy, d equals 57 over 19. And if I do 57 divided by 19, I get the number 3. So now we see that y is 3. If you didn't already do it, do z now. here for dz, this determinant becomes 76. So to figure out z, dz over d, that's 76 over 19. And 76 divided by 19 is the number 4. Oh, using Kramer's rule, you get the determinant of the x and divide it by the main one, determinant of the y divided by the main one, determinant of the z and divided by the main one, and you can get what x, y, and z are. It's simply another method of solving a system of equations, but it's one that can be very appealing, especially to a computer, a technological method, much faster for computers to do this than the way we do it by hand. But even by hand, once you know these numbers, this is a way that makes sense to solve these. It's a pretty easy way to solve these. So now for determinants, see that you know how to do 2 by 2 and a 3 by 3 and Kramer's rule, and you know how to enter these in and get these numbers. So now you've practiced a few of them too. So those are the primary things to know about determinants.